Hello, all of the keynote speaker, the lecturer, and all of the presenter of the ICONETSI 2020. Thank you for coming in my presentation. I want to introduce myself. My name is RFKP Tarigan from Polytechnic Manufacture Astra, and I'm the student in the Swiss German University also. My first advisor is Mr. Ari Syahriar from University Al-Azhar Indonesia and also the lecturer in SGU. And the second advisor is Mr. Yohanes Climacus Sutama from Polytechnic Manufacture Astra, head of automotive. So my theme is about the thermostat influence simulation during warm-up period in the spark ignition or gasoline engine cooling system. So the study showed the simulation of thermostatic valve in the cooling system of spark ignition engine and the behavior of warm-up period for different ambient temperature. There is a condition in the workshop on the field. If there is a malfunction on thermostat, the fastest solution to do is remove the thermostat. So with this study, I want to show if we not use the thermostat, we have the time longer than a system with the thermostat to reach the working temperature of an engine. I use the experimental data and I use a simulation and also the mathematical equation to solve the problem. So as an introduction, this picture shows the energy loss due to the cooling system. We have 26% in the gasoline engine and 19% in the diesel engine. This picture shows that the cooling system have a major impact after the exhaust gases. So the primary function of the cooling system in the automotive engine, the first one is not to cooling down the temperature, but is to warm up, to reach the operation temperature as soon as possible. Okay. And then after that is to remove excess heat due to the process on the engine. I mean, it's combustion engine. So the thermostat itself placed after the engine is like a valve connects the branch from the engine to the radiator and the pump. In the warm-up period, the thermostat closed the way to the radiator and open the pipe or the way to the pump, so the coolant can going from the engine thermostat and going to pump without cool it down. So that's the maximum temperature reached as fast as possible. And after the engine reached the operation temperature, the thermostat is open the way to the radiator and close the way to the pump. So the coolant could be cooled in the radiator system. So I have three methods here. First is data collecting. I use the sport utility vehicle as an experimental vehicle. I using the OBD2 scanner device. I using the function of the scanner device is the data stream function. And then I using the simulation, using the Simulink. And I do some kind of mathematical analysis to make a new equation. So this one is the simulation with Simulink and the experimental data. The cooling system in the first simulation is using the thermostat, and then I eliminate the thermostat to see the graph of the engine without the thermostat and with the thermostat. If we click this engine and the subsystem of the engine is going like this. So the result of the simulation is as shown in this figure. Without thermostat, this blue line, and with thermostat with this red line. So this is the proof that the thermostat make the engine reach the temperature faster than without thermostat. I calculate this is more than 3 times faster with thermostat than without thermostat. Okay. And this graph is the experimental data graph. This graph is the complete graph of the engine temperature. This one is a coolant temperature. Coolant temperature is reversed to engine temperature, and this graph is time. So in the first picture, previous picture, I mean, we concentrate on this period. This is the warm-up period. And in this point, the thermostat is already open. If thermostat is already open, so the coolant is be cooled in the radiator. That's why the graph is not going a little bit flat here. And after the heat comes from the engine, they going rise, and then the fan is on in this point, on, and then off, rise again, and so on. So I used two different ambient temperature for my experimental data. This 31 Celsius and 29 Celsius. So with this model, with this graph, we can see the shape is like the exponential function. So I create the new formula of this graph using the exponential function. First, I looking up the gradient with this equation, and the result is 4.19 times 10 power by -4. And then the B number is like this. Every time with the power by 0 is becoming 1. So the complete equation is Y or the temperature is 303.15 exponent of 4.16 times 10 power by -4 times X, like that. So this equation have this point, the orange point, and the average graph for the ambient is like this. Okay. So the equation is a little bit closer to the reality of the experimental data. So the conclusion here is the simulation has been made with Simulink. It shows that the system without thermostat have more than 3 times longer than the system without with thermostat to reach the working temperature of the engine. Using the experimental data from the OBD2 device, the ambient temperature difference of 2 degrees Celsius have a little effect to the graphic result, but in extreme condition, the ambient temperature could affect in wet rags. So the equation have been developed for that. Thank you so much. I hope I can reach the feedback from all of yours. Thank you.